Hi everyone, this is Dr. Nowley again. So remember that in the previous video, one of the things we discussed was this idea that we can differentiate between different types of aqueous solution using their ability to conduct electricity. And we call things that conduct electricity solutions that conduct electricity strongly, strong electrolytes. And those that don't conduct very strongly, we call weak electrolytes, and those that don't conduct at all, we call non-electrolytes. Now, in the description of strong and weak electrolytes, I said that compounds that belong to this group in terms of ionic compounds are called soluble salts. So salt is just another word to call ionic compounds. So basically anything that's formed by a metal and non-metal, cations and anions. And then we also say that there are certain salts that are insoluble, meaning that they don't dissolve a lot in water. They dissolve a little bit, but just usually a very small amount, okay? And I give you some examples of these soluble and insoluble salts, and I said that I'm going to discuss more about them in this video, and that's what I'm going to do right now. You can basically, it turns out that if you have a salt or an ionic compound, there's a range of solubility that you can have. In other words, salt can be very, very soluble in water. In other words, you take 10 grams of a salt and you put it in 100 milliliters of water. Given the type of salt, sometimes you can find salts where 10 grams will completely dissolve in 100 milliliters of water. Sometimes you'll find that when you put 10 grams of a particular salt, only maybe 0.1 gram of that salt or 0.01 gram of that salt will dissolve in 100 milliliters of water. Okay, so in Chem 11 we don't really discuss quantitatively how to differentiate between these different salts. However, we have these qualitative rules, and that's what we call the solubility table. And this is something that you have to memorize in Chem 11 because there isn't really anything else that you can have except to memorize this. And memorizing this actually will be useful for you when you go to Chem 12 because you'll be encountering concepts of solubility again, but in a different context, but knowledge of the solubility table will kind of carry you quite far in understanding the concepts that you'll discuss in Chem 12. So the solubility rules are given here. I don't want to read off each one of these, but it's just for you to know that you should memorize these and kind of have them in your head when trying to determine whether a salt that you have in front of you, an ionic compound, whether it's soluble or insoluble. Okay, the ones that to keep in mind, they're fairly straightforward, is that whenever you have a group 1 element as your cation, lithium, sodium, potassium, rubidium, cesium, and francium, or ammonium, okay, those type of salts are always soluble. So if you combine sodium with chloride, you always get a soluble salt. You can combine sodium with sulfate and you'll be soluble, and so on. Okay, those are kind of the really easy one to keep in mind. The second one is also fairly easy. This refers to anions now. So if you have nitrates or chlorates, perchlorates, or acetates, these are always also soluble. So anytime you have cations combined with these guys, let's say you have iron nitrate, that's going to be soluble. You have copper chlorate, that's going to be soluble, and so on. Okay, and then the other ones are basically more specific. There are certain exceptions to each one of these rules, and you have to remember all of them. Okay, so that's all I'm going to say about the solubility rule. When we put them in practice, I think it'll be in examples. I think it might become more useful at that point. Okay. Let's now talk about writing reactions that contain aqueous species. Remember what I said earlier, when we have something like an ionic compound, when we write them in water, right, they don't really exist as the ionic compound anymore. So even though we can write this formula, NaCl aqueous, but that really is not reality. Reality is this, that the sodium chloride compound breaks apart into sodium ion and chloride ion, and they're each surrounded by a bunch of water molecules. As a result of the fact that you can have these different forms of the salt being written, we have 3 different types of formulas or equations that you can write with respect to aqueous ionic species. Okay, And these are the following. The first one is what we call the molecular or the formula equation. This is really the one where you're going to write the ionic compound as its formula unit. So for example, you're going to write things like NaCl aqueous in this case, even though it doesn't exist, but you're going to write that out. The second type of equation is something we call complete ionic equation, which means here, instead of writing the sodium chloride as sodium chloride aqueous, you're going to write it as sodium plus aqueous, and then you're going to write it as Cl minus aqueous. Okay, so that's what we call the ionic, the complete ionic equation. Okay, which is, in some senses the I'm just gonna make this a superscript. That's the one where we just write out all the ions. Okay, and then the last one is something we call net ionic equation, which, as it turns out, in reactions, in aqueous reactions, not all the ions are always involved in the reaction. Sometimes the ions are present, but they're not participating in the reaction. Whenever the ions don't participate in the reaction, we call them spectator ions, and we remove them from the net ionic equation. So the net ionic equation basically just shows the species that participate in the reaction. Okay, so what I'm going to do is close off this video by giving you an example of how to write all these three equations given this reaction. So here the reaction is silver nitrate with sodium chloride, and it produces a precipitate called silver chloride, and sodium nitrate remains aqueous. And then I ask you to write all of these things. Okay, one thing I want to mention to you here that I didn't mention just now about the molecular complete ionic and net ionic equation is that the complete ionic equation, we write it for the ionic compound that's dissolved, right? So that means that things that do not dissolve, the ionic compounds that don't dissolve, are written as their formula unit, okay? So dissolved ionic compound is written as separate ions, but undissolved ionic compounds are written as its formula unit. What are some examples? Excuse me. For example, AgCl doesn't dissolve in water. It's one of those insoluble salts if you go back to your solubility table. So as a result, we don't write AgCl as Ag plus and Cl minus, but we write it as AgCl solid because it doesn't break apart into Ag plus and Cl minus. Another thing that you might consider writing together are things that are in liquid state and in gas state. Okay, these are usually undissolved in water, so even though they're in water, but they exist not as the dissolved species, but it's just, they just exist as their own species, separate from the water, separate from the dissolved compound. So for example, we can have things that are oil, for example, is a liquid, doesn't mix, so you're not going to write that as some kind of positive or negative ions. There are other things as well that gases, for example, there are certain things that form gases, SO2 being one. They're not going to, again, dissolve in water, so you don't write them as ions, you just write them as SO2 gas. Okay, so those things that are together, that are either in solid, liquid, or gas state, they don't really form ions, and because they don't form ions, and you don't write them as the separate ions as you would for something like sodium chloride. Okay, let's go back to this example now. We have silver nitrate, we have sodium chloride, we mix them together and we get a precipitate, silver chloride. So that means that it tells you that that's a solid state, that the word precipitate basically means that you have a solid, and sodium nitrate remains aqueous. So you have another product called sodium nitrate, and that's aqueous. Write all of these guys, okay, different types of equation. Okay, so we'll work on that now. So let's start by writing just the reactants of this reaction first. So we were told we have sodium chloride, and then we have silver nitrate, and then we know that we produce silver chloride as a precipitate, and then we also produce sodium nitrate as an aqueous solution. So you're going to write this first, complete it like this, solid, and these two are aqueous to begin with. So then that would be our formula equation. So this is your the one that the first type, which is, so this is your formula or your molecular equation. Okay. Now, after this, then what we do is we can write our complete ionic equation, and what that is basically just taking each one of this that's aqueous and separating them into the cation and the anion. So in this case, sodium chloride is aqueous, so we're going to take that apart and separate them into Na plus and Cl minus. This one is also aqueous, so we're going to take that apart and separate it into its cation anion. This one you notice is a solid, so we're not going to do anything with that one because solids don't break apart. They're insoluble in this case. And then lastly we have NaNO3, which is also aqueous, so we're going to take that apart as well. So then your complete ionic equation would look something like this. Na plus aqueous plus Cl minus aqueous plus Ag plus aqueous plus NO3 minus aqueous. Okay, I'll write the product at the bottom here, arrow, to AgCl solid and Na plus aqueous and NO3 minus aqueous. Okay, so that's your complete ionic equation, and let me just write that down right here as your complete ionic equation. Okay, it's this one right here. Now as you can see, from this equation I can tell that there's some ions that basically are not really involved in the reaction, and I can identify them by looking for ions that are present both in the product and then the reactant, and they're present exactly the same look. So in this case, sodium plus, you notice that it's sodium plus aqueous here in the reactant, and when you look at the product you still see sodium plus aqueous, so that means that that is what we call the spectator ion. So they're not really involved because they look the same exactly before and after reaction. Another ion that looks like that is your nitrate ion, right one here. That's in the product, here is in the reactant. So we also cancel this out. And whatever's left at the end, those are the ions that actually undergo the reaction. So we're going to write those out. Usually start with the cation, Ag plus aqueous plus Cl minus aqueous, forming AgCl solid. Okay, now this last equation here, this is your net ionic equation, because now you have just the ion that participate in the reaction is written. So this is called the net ionic equation. Okay, and I said earlier, any species that's either solid, liquid, or gas would basically stay together, so they'll be written as a compound, and then anything that's aqueous can then be separated, just as these examples here with your sodium and the nitrate ion. In this case, you know, all these salts that are aqueous to begin with, they all got broken apart into their ions. Okay. All right, so that finishes the first series of videos on aqueous reactions. In the second series of videos, I'll talk about molarity and concept concentration.